Now let's look at combinations. Look at this problem. So, same 14 students, but how many teams of 3 could I choose for a math contest? Notice this isn't a counting principle or permutation one because there's no slots for order. There's no one finishing first, second, or third. So the order doesn't matter. So what that means, if I'm choosing a team, I could choose Ralph, Bob, and Tammy, and that's the same as if I had Tammy, Ralph, and Bob. Same team. So when I see that order doesn't matter, I immediately go, okay, it's probably combination, and this is done with a button on the calculator. NCR. So with this problem, 14 students, how many combinations of 3? That's the second on the 8. 14, 8, 3, 364. Combinations are as simple as that. You just have to decide, does the order matter or not? So compare this to example 6 in the book. In example 6, we're looking at nurses. 11 nurses, and every night there's 5 on duty. How many different ways can a team of 5 be chosen? Well, this is just like the last problem. When I see team, I'm going, okay, it doesn't matter. It could be any combination of the 5. I don't know what that was. So there's 11, C, 5. $462. Okay, to do one big problem with combinations. In fact, I'm going to put a couple of things together. I'm going to put combinations together with the counting principle. I'm going to look at the Powerball lottery. I don't know if you've played Powerball, but what you do is you select 5 numbers between 1 and 69. And we don't care how these 5 numbers come up. Order doesn't matter. It's a combination problem. You also have to select the Powerball between 1 and 26. So how many ways can this Powerball come up? How many outcomes for Powerball? Well, let's do this part first. Then we'll put it together. We don't care about the combination. So we're choosing combinations of 5 out of 69. So that's going to be a big number. One, 1, 2, 3, 8, 5, 1, 3. a little over 11 million. Now at the Powerball, there's only 26 outcomes there. Well, we got to put these together because it's really an and. So we're going to multiply these. So it's this number times the 26. Notice what that did to our number. It went from 11 million to 292 million. And here's why Powerball did that. They're trying to make money in the lottery. So they want people to play Powerball. Well, if you just had this, the probability of winning is 1 over that. You have to have the perfect 5 numbers in order to win. So think of when people go nuts for Powerball. It's when the pot gets really big. Well, with this probability, someone's going to win roughly when it gets up to $11 million. And so people weren't buying enough. So you add these 26 outcomes with the Powerball. Suddenly, your probability of winning drastically less. And now look where I guess the prizes are now starting to get up to the big ones. So, you know, when it gets up to that 300, 400, 500 million, people really start to play. So it makes more money. Okay, try some of these practice problems. See you in office hours.